Okay, just give me a minute. I'm sharing the screen. Others, can you hear me? Yes, screen is not yet shared. Just give me a second. Okay, great. Can you see my screen now? Is my screen visible to everybody? I shared my screen. I hope you are able to see my screen, everybody. Okay, chalo, great. So once again, good evening everyone. So in the last session, we started with the project. Finally, we started with this embedded project. So in the last class, in detail, we discussed about the requirement of the project, what and all things we need to do with respect to our microwave oven project. In detail, we discussed that. Later, while doing the implementation, if we need, we will revisit once again. Okay. So since we are working on the embedded project, so we started with the introduction to the embedded system. Am I right, people? So in the last session, we started with the introduction. So in that introductory session, we saw basically what is embedded system definition. So obviously you're working on embedded system, you're designing the embedded system. And if you don't know what it is, it doesn't go well, right? So we saw basically what is embedded system. Then later we discuss few examples regarding the embedded system as mentioned in this slide, right, people? And then after that, we even in the last class discussed different categories of the embedded system. So people, many examples you mentioned with respect to many categories, with respect to these categories, but it's not possible to find for me to pick each and everybody's example and say, yeah, this is the example of this class. That's fine. So you, based on whatever discussion we had, so you can decide it is example of which category. It is possible that whatever embedded system example you are saying, it may fall under the multiple categories. That will be the hybrid system. Okay, now in today's session, let's go ahead with the most important component, most important slides, which is talking about the components of the embedded system. So people, if you ask me, most important or the heart of the this embedded system is nothing but the microcontroller. So people, so here if you see, this is the most important component of your embedded system. So you can see here microcontroller is mentioned, SoC is mentioned, and microprocessor. So any idea what is the SoC here, guys? Yes, very nice, system on chip. So thing is what, people, so you can do the development, you can design the embedded system using the microcontroller or even by using the microprocessor. But people, if you're going with the microprocessor, things will be little complex. Means microcontroller is having all the components built in, not like microprocessor, right? So usually we prefer the microcontroller in embedded system over the microprocessor, right? But still, if you want, you can use the microprocessor. Okay, that's fine. But why SoC? Why system on chip is included here? Because guys, thing is what, as you're proceeding with the complex application, then it is possible to implement that application by using the single microcontroller. It's possible to implement the microcontrol embedded system. Let's say you are designing the embedded system and it's very complex, it's very complex. Okay, then it's not possible to go ahead with the single microcontroller. So that time you may need a SoC. What is SoC? As you said, system on chip. Yes, you may need more than one microcontroller. So SoC might be, SoC is having the multiple microcontroller in it. So as task is becoming complex, you can go with the SoC. That's why in the components of embedded system, SoC is also included. So you can see very first important component of embedded system is nothing but the microcontroller. So either you will be having microcontroller or SoC, system on chip, or the microprocessor. Anyways, don't worry about this. So here in our embedded system, whatever development we are doing, whatever development we are doing in that, don't worry, we are what working on the simple embedded system application, which is nothing but microwave oven, which is not much complex. So we will be going with the microcontroller. Fine. Okay, so first most important component is nothing but this. Then later, if you see this as a heart of the embedded system, another most important component is nothing but the memory. Okay, this you can think like a brain of the embedded system. So guys, any idea what are the different memories in the embedded system? If I categorize, if I talk in terms of different types of memories in the embedded system, what are those? Talk in terms of embedded system. Very nice. Very talk in terms of embedded system. That's what I am asking. See here. Nice, nice. So you can have, okay, let me take the category as a see here. So you may have an embedded system as a ROM, right? As you are mentioning correctly. Then another category could be RAM memory. Okay. Then third category could be hybrid memory. Fine. Okay. So now, may I know what is what is ROM stands for, people? What is ROM stands for? It is nothing but the read only memory. Am I right, everybody? Okay. And what is RAM stands for? RAM is nothing but the random access memory. Okay, fine. Chalo. Let's try to understand. What do you mean by ROM? By name itself, we are understanding it is a read only memory. That means we can just do only read operation from this ROM. We cannot write into this. Basically, it is designed just to do the read operation. Then, if I talk about the RAM memory, then random. Okay, random. Let's try to understand the meaning of this. Random means what? Anywhere. Access means what? Read, write. So people, so from this RAM, from anywhere, I can perform what? Both the operation. I can do the read, I can do the write operation also. And there are going to be hybrid memories. I will talk more about that. So first, let me pick the ROM memory. Fine. Okay, let's discuss in detail about this ROM memory. So people, this ROM is nothing but the read only memory. Okay, so guys, do you have any idea what are the different types of ROM? What are the different types of ROM memories in the embedded system? First one, let me help you to pick the first category. Nice, nice. How can you say SRAM, Baba? In the SRAM name itself, RAM is there. Now I'm talking about the ROM. Let me very clear. So one category you are having what? PROM. As few of you are saying correctly, PROM. So PROM is stands for the programmable read only memory. Okay. So it stands for what? Programmable read only memory, right? So people. So usually this memory is what? A factory program. But if needed, what happen? You can program this memory. If you want, you can program this memory. But how many times you can program this memory? PRAM, you can program how many times? Just a one time. So it is just a one time programmable. So once you program, you done the code in this memory, finish. You cannot use this. So this is what? Just what? One time programmable. Though it is programmable, but you can program only once. So because of this, it is also referred as a OTP, which stands for the one time programmable memory. Okay, so guys, if you see the application of this memory, so let's say whatever toy industry is there now. So in the toy industry, you can see that this type of memory is used. So just you are what? Designing the toy, whatever code is there, you're burning into this PROM, and that toy is ready. Just one time program. That's it, nothing more. So this is about the PRAM or the OTP, one time programmable read only memory. Fine. Then another category. So let me talk about the another category of the ROM. It is nothing but the EPROM, as you are saying correctly. Yes, EPROM. So EPROM stands for what? EPROM stands for what? It stands for the, come on, I'm sorry. Already you know the PROM stands for programmable read-only memory. So PROM stands for what? erasable, okay, programmable, yes, erasable, programmable, read-only memory, right? Correct? Okay. And this PROM is just a programmable read-only memory. Okay. So now guys, see here. So this type of memory, EPROM. So what you can do from the name itself, we can understand that we can erase this memory, okay, and we can reprogram. So if you want, if needed, whatever code is there inside this memory, we can erase that and we can reprogram this memory. It's a erasable programmable read-only memory. Fine, we can erase this. Okay, fine, it is saying that this memory is erasable. That means you can erase the contents from this memory, but and then you can reprogram it. But question arises, how can we erase this? How it is erasable? It is that simple to erase this memory? No. So basically, to erase this, what you have to pass? You have to pass the UV rays, or you have to pass the UV light, and then whatever contents are there, those are erased, and then it will be reprogrammed. Now people, okay, so now question arises, though it is erasable and reprogrammable, then why it is coming under the read-only memory category? Because let's say you purchase the product, you have a one product which contain EPROM, so you want to erase the data from that EPROM. So at your home, are you going to pass the UV light and are you going to erase that memory? It's feasible? No, right? Obviously no. Correct, everybody? Not possible. So that's why it kept it under the ROM category. So basically, if you talk about the usage of memory, example where it is used, so it is basically used in the labs, or it is used in the R&D center, where the research and development is happening in the labs, or even in the R&D center. So where what research is happening, so there what you can do, you can program this memory. If you want, you can pass the UV light and you can erase it. It's possible in the labs, it's possible in the research and development centers, but obviously not at home. Okay, then another category of the ROM is nothing but the what, as you said earlier, it is nothing but the mask ROM. So what is another category? It's nothing but the mask ROM. So people, mask, what is the meaning of mask? MROM, okay, even it is called as a MROM. So what is the meaning of the mask in general? English meaning, I'm asking. Mask means what, people? Mm-hmm. Mask means what? Mask. If I ask you the meaning of the word mask, yes, mask is nothing but the hiding, right? Mask is masking. Masking means what? Covering is nothing but the hiding, right? Yes, no, yes, correct. Whatever you are saying is right. So people, what happened in your program, in your embedded system, or in some applications, okay, there are the certain real certain sections which we need to hide, which we need to cover. So usually this mask ROM are the factory program. So user is not programming, user is not having the access to update this memory. So people, what happened, there are the certain regions which we have to kept it masked, we have to kept it covered. Means, for example, let's say you develop some embedded system, you use few chips to work on that embedded system, then whatever is that chip ID, lot number of your product, so those things what you have to store it in your application, but at the same time you wanted to hide it from the user, then you will store it in the mask ROM, and user is not having the access to this memory. So usually it is masked. Okay, so here if you see the example where it is used, so whatever bootloaded program is there now to boot to start your system, whatever booting sequence, whatever bootloader codes are there, those will be maintained in this particular memory PROM. So usually it is what, factory program, user cannot modify it. Fine. So this is about the ROM. So do you have any doubt still whatever we discussed? I can understand you are talking about the different examples of the different memory. We will see that. See, bootloader means We will see that another memory. I didn't completed the topic yet. I'm just completed the ROM. So bootloader is nothing the program which is having the startup sequence to start your machine. That is nothing but the bootloader in very simple term. Okay. So can I start with the RAM? Let me start with the RAM now. So people, RAM. RAM stands for the random access memory. Okay. So guys, RAM is nothing but the random access memory. So how many types of RAMs are there? Any idea? Do you have any idea how many types of RAM memories are there? Two are there, right everybody? Yes, not okay. NVROM is extended version of SRAM. Okay, so basically how many types of high level if you talk, I'm sorry, how many types of RAM are there? Yes, there is a DRAM and there is a SRAM. Nice, nice, nice. Okay. Okay, great. So D stands for what? Dynamic. S stands for the static. Dynamic random access memory, static random access memory. Fine. I will not waste the time in writing the full form. You know already. Okay. So now people, you know this memory. I'm just revising it. So to understand this DRAM, to understand this DRAM, let me take one analogy so you can understand it. Okay. Let me ask you. Guys, have you ever saw this movie? I know the Hindi version. South Indian version name I forgot it. So it's there is Amir Khan in this movie, and I think in the original one Surya is there. To be honest, I don't remember the actor's name in both the versions. Okay. Anyways, have you seen this movie? Everybody, come on. Now we are not talking any technical things. Okay, no, if you didn't, no problem. Yeah, I think it's a Surya is there in the original version, and in Hindi version, Amir Khan is there. Yes, yes, correct, fine, absolutely right. So may I know? I just have a concern. I just have a concern. What is the issue with the lead character? Whoever is the leading character of this movie, what is the issue? What is the issue? Yes, you watched that movie. Now I'm asking, what is the issue? What is the issue of that lead character? Memory loss. Okay, fine. Use a proper word. So there is a permanent memory loss. There is a permanent memory loss. Use the proper term. So as you people are saying correctly, can I say there is a short-term memory loss? Can I say? Yes, people, don't worry about the original name and all this thing. I just have a concern about this term, short-term memory loss. Just pick the analogy and discuss the technical term. Yes, so it has a short-term memory loss, right, everybody? Same issue is having with this dynamic random access memory. So this memory also having the same issue. So this memory is also having the short-term memory loss. So what happened? What happened? So for this dynamic random access memory is also having the short-term memory loss. So what happened? What happened? Whatever data is stored in this DRAM, it will be stored for some dynamic amount of time, some short-term duration, and it will be erased automatically after some dynamic amount of time. So whatever this character of this movie having issue, same issue is having in case of this DRAM also. So they basically what happened, there is a charge refreshment is happening here. So it might be internal. I don't want to go in detail how it is manufactured. So thing is what, there is a capacitor in it. So a charge refreshment is happening means it is getting charged, it is getting discharged, and by that time whatever data is stored in that DRAM, it will be erased. Right, Ruchir? As Ruchir is saying, it need to be refreshed consistently. Correct. Charge refreshment is happening, and due to that, what happened? Whatever data is stored, it will be there. Still, charge is there. Once it is discharged, we will lose the data in case of DRAM. So, people. So, due to the charge refreshment, what happened? It will consume more power. Okay, and what happens? So okay, now if I talk about the SRAM, so in case of SRAM, as you are aware, so still what point data will be stored in case of SRAM? Yes, let's not go in detail, Shakil, how it is implemented. So we are I'm sorry. So we are just talking as a user how we are going to use it, how those are working, not doing any development. See, SRAM, in case of static RAM, data is stored. Still what? Still power is there, right? As soon as there is a power loss, what happen? We are going to lose the data. Okay. In both the memory, DRAM and the SRAM, still there is a data, still there is a power, there is going to be data is saved. But as soon as, specifically in case of SRAM, as soon as you lose the power, you're going to lose the data. Fine. So your data is stored, still you have a power. Okay. And what about the power consumption? I mean, in case of SRAM, there is no charge refreshment. So due to that, what happened? As compared to the DRAM, it consumes less power. Okay. And the DRAM is having the more density, it is more dense. Okay, and due to that I'm doing a typo mistake, please ignore it. So due to that, what happened, you can see this DRAM memory is basically used in your computers. Whatever RAM you see in your computer now, that is nothing but the DRAM. And this SRAM, static RAM, what happened with this static RAM? So this static RAM is less dense, its density is less. So due to that, what happened, we can store the less amount of data in that. So if you see the applications of this, whatever microcontroller memory you are able to see now, microcontroller is having this much RAM, that much RAM, or even cache memory if you are talking about now, those are nothing but the SRAM only. Understanding? So this is about the DRAM and SRAM. So basic difference, are you able to understand, guys, about between the DRAM and SRAM? So PRAM, Nitin, we already covered it. We already done. I hope you join on time. Understood? Somebody is asking cache memory. Yes, SRAM is used as a cache memory. Getting? OTP is one-time programmable, full form. PRAM is programmable read-only memory. OTP is one-time programmable memory. Okay. Fine. Now let me talk about the hybrid memory. Okay. Now let me talk about the hybrid memory. Now, hybrid memory means what? Now, see, hybrid memory means combination of, you can say, your RAM or ROM memory and the RAM memory. I mean, anytime if I need, anytime I can delete the contents from my hybrid memory, or anytime I can retain it. So if you talk about the raw memory, register read only memory. If you need, you cannot erase the data from it, right? And even in case of RAM, if DRAM or SRAM having some disadvantages, let's say if there is a power loss, if you want to retain the data, you are going to lose it. So don't you think you need a hybrid memory? Means, for example, to understand this, what I'm saying, that in case of hybrid memory, what we can do, anytime we can retain the data, or whatever time we want, we can retain the data, or whatever time we want, or whatever data we want, we can erase that. Okay, now see here, let me take the example of one very frequently used example. Let's say you have a mobile phone, and in your mobile phone, let's say you're taking a selfie. Okay, usually we all take the selfie. Fine. Usually what we do, we all take the selfie. Fine. Now if you see, let's assume in your mobile phone, for the storage purpose, they are using the PROM. Okay, programmable read-only memory. So let's see this one scenario. Let's say if you have only RAM, only ROM, let's say there is no hybrid memory, how things will work. So what happened, whatever your storage you are having is the PROM. Now let's see this scenario. Everybody, let's say I took a selfie, and where my selfie is stored in my phone, let's say it is stored in the PROM. And guys, let's say honestly, that selfie is not at all good. Background light is not good, angle is not good. Basically, I didn't like that photo. So I want to delete it. What I want to do? I wanted to erase it. I wanted to delete it. So can I do that? It's possible to delete that in case of PROM. It is just a one-time programmable. Once you written finish, can you reprogram it? Can you delete it? So answer is what? No. See the issue. Can you delete it? No. So it is permanent. It is stored there. Okay. Let me take the another scenario. Let's say you took a selfie, and let's say you have a SROM now. So where it is stored? It is stored into the SRAM. Fine. Now see here, okay, chalo. You're saying that EPROM you can use. Let's say here you have a EPROM. Okay, fine. It is stored into the EPROM. So I want to delete it. So guys, in this case, even if I have EPROM, am I going to pass the UV rays to delete that photo? Are we really? It's feasible. I have my mobile phone. Let's say you have your mobile phone in your hand and there is a EPROM in it and you want to delete some data. So are you really going to pass the UV rays? And are you going to delete it? It's feasible even. Yes, no, obviously no. Right, everybody? Chalo. Now let's talk about the SRAM. So let's say I have a SRAM. Let's another scenario. So I took a selfie and it is stored into my SRAM. Now this time, my photograph is very nice. Huh? Background light is good, angle is good, everything is fine. I like that photo very much. Okay. Now I wanted to keep it stored. I wanted to retain my photo. I don't want to delete that. Obviously, if it is good photograph, everybody want to retain that. Now, unfortunately, what happened? I'm running low in my battery. My phone got discharged. Okay, it is completely discharged. Okay, then what happened? Let's say I was outside, it got discharged. Then I went to home, I charged my phone. Okay, and after charging it, I just turn it on. Okay, then what about my data? What about my selfie? In that case, so here if you see, it is discharge means what? Here you got the power loss. Okay. So here I lost the power. Here is the power loss. So what happened with the data if you have a power loss? It is going to retain that data. Don't you think whatever data was stored in the SRAM is lost? Don't you think I'm going to lose that selfie, lose that data? Am I right? So don't you think here comes the need of hybrid memories? In which if I want, I can delete the data, in which if I want, I can retain the data. Agree? Agree? So here comes the read of the hybrid memory. So what are the different hybrid memories we are having? So there are the first hybrid memory. Let me pick, which is nothing but the double EPROM. Many of you are saying that, ma'am, double EPROM is not picked, double EPROM is not picked. So here comes the first hybrid memory, which is nothing but the double EPROM. Okay, so double EPROM is what? It is electrically erasable programmable read-only memory. So guys, so this memory is what? Erasable. Okay, and guys, do you need to pass the UV lights to erase and reprogram this memory in this case? In case of double EPROM, do you need to pass the UV light in this case? No, it is electrically erasable. No need of UV light, right? So it is electrically erasable, read-only programmable memory. So you can erase it electrically and you can reprogram it. No issues in this case. But people, this memory is having one issue. So here in case of double EPROM, so basically what you can do, you can write the data. Okay, means erase it, write it, and you can read the data. So you can do the both the operation. You can read it and you can write it. Erasing the contents and rewriting is not difficult in this case. But here, this memory is having issue with its write cycle. Okay, or not, no issue with the read cycle. What happened? There's a issue. It's not issue actually. Actually, it's write cycle or writes. You can say that here in case of double EEPROM, write cycle is slow actually. So what happened? Even to write a single byte of memory, it is taking time around, all an average. If I consider, it is taking 1.5 millisecond. Do you understand? It's a very big time. Now imagine you want to write a, let's say 10 bytes you want to write. So how much time it will take? Don't you think it will take 15 milliseconds? It's a very big time, correct? It's a very big time, correct? So double EEPROM is electrically erasable, programmable, read-only memory. So writing a byte is going to be slow here. Write cycle is slow. So due to this, due to the write cycle is slow, what happened? So basically, this memory is used to write or to store the less amount of data. So whenever you have a small storage, if you want to store lesser data, then prefer it. Why? Because if you have more amount of bytes, it is going to take the more time. So usually one byte take the 1.5 milliseconds. So here for the storage of the less data, this double EEPROM is preferred. Okay, and due to this disadvantage of double EEPROM, other hybrid memories are coming into the picture. What are those? Those are nothing but the flash memories. Okay, so in the flash memory you can say that there is a NAND flash. Okay, and there is what? NOR flash. Fine. So there is a NAND flash memory and there is a NOR flash memory. So first let me talk about the common points about both the memories. So people, both your NAND and your non-flash memory, those are block memories. I mean, they can access by the block, and size of block is totally dependent upon the architecture. You can open the data sheet and you can check it. So usually, even if you want to update a single bytes or single bit in this memory, you need to erase the entire block of this memory. Okay, and then you can update the data. It is block access. These are the block memories. Okay, and if you talk about the difference point among the NAND and flash, not flash memory, so first point is nothing but the, it is less reliable. If you talk about the NAND, it is less reliable. Okay, anytime bad block will occur and you will lose the data, whatever is stored in case of NAND flash. And if you talk about the NOR memory, it is more reliable. Okay, then another point in case of NAND, it is more dense. Density is more. Okay, ignore the typo. And if you talk about the NOR flash, what happened? It is what? Less dense. So now I'm saying density. Okay, this term is appearing second time. So what do you mean by density? You know, people, density means what? Let's say I have this density means in simple term, if you have a particular memory area, so in that same area you can store the more data. Means let's say this is my chip, and let's say it's this area is nothing but 1 centimeter square. Let's assume that. Okay, so people, if I go with the NOR flash, which is less dense, so in this area I can store around few MBs of data. Okay, let's assume. And if I go with the NAND flash, then within the same area, I can store the more bytes. So you can say here, I can go with the GBs of data. So that's what the density means. So within the same area, I can store the more data. Understood? More density, you can store the more data. Less density, you can store the less data in the simple term. Correct? Chip space and all technical terms you are using correctly, but I'm using the simple term to explain it so that everybody can understand. Fine. Okay. And another important thing here is nothing but the this NOR flash. It support the XIP operation. XIP means what? XIP means execute in place. Okay, don't get confused this NAND and NOR flash memories with the logic gates. Not the same, it's different. Okay, so this what NOR flash, this memory supports the XIP operation. So what do you mean by XIP? XIP stands for the execute in place. Okay, so now people, what happened, so usually this NOR flash is used to storage of the code, and this NAND flash is used for the storage of the data. So what happened if you store the code, okay, in this NOR flash? Now see, still now what you saw, you are writing the C program, let's say in this main.c, you are writing the C program, and that C program is converted into the executable file, let's say a.out. Okay, and then guys, to run the program, okay, like this, to do /a.out to run your program, don't you think first you have to load this program into the main memory from the secondary memory? So if you run this, if you write the program, or even if you create executable file, it is stored in the hard disk in the secondary memory, right? But to run that program, you have to load the program from the secondary memory to the RAM usually. But here, since it supports the execute in place, if your code is stored in the particular NOR flash, then there is no need to load the data into the RAM. Directly from that memory, it can be executed. And since it is more reliable and it supports XIP, it's used for the storage of the code. And NAND flash usually used for the storage of the data. Understood? So these are the different memories in the embedded system. Getting it, people? Full form, see, Kedar, you are stuck with the one question, full form, full form, full form. See, full form is same, and is not of and, kind of the same. But here we are using in terms of the flash memory. So just to avoid the confusion, I'm not going with the implementation because we are not designing the any embedded system memory here. Memories are already there. So if you see the Pixim lab, in that already microcontroller is there, it has already built-in memory, we will be using it. Okay, see, less reliable, more reliable means what? If you see the example of where the NAND flash is used, guys, all of you are using the pen drive, all of you are using the pen drive, yes, you are using it. Okay, now uh, are you sure means whatever data is stored in the pen drive, it is going to be it is going to be safe always? Are you sure about that? Don't you think any time from your pen drive data is getting corrupted? Anytime from the pen drive data is getting corrupted, right? So why? Because it's a less reliable. Anytime bad block will occur and it may corrupt your data. That's the meaning of less reliable. Okay, and compared to that, NOR flash is more reliable. Understood? Hybrid memory means the memory which is having the properties of both ROM and RAM. That is nothing but the hybrid memory. So in case of hybrid memory, anytime I can delete the data or anytime I can retain the data. So this is about the different memories in the embedded system. Now think little bit, guys. I am getting the examples about what this one. Examples about the Google Drive and all. So are you sure in embedded system? Have you ever seen the Google Drive? Think little bit before asking the question, guys. We are talking the memories of phone embedded system, right? In embedded system, do you see the Google Drive and all these memories? Do you understand? Yes, these under the hybrid memories. Okay, under the hybrid memories, you will be have a first time taking double prompt. Okay, let me note down here. So we discuss about the ROM memory, in which we discuss the PROM. Then in this ROM itself, we discuss about the mask ROM. Then under this category, even we discuss what EPROM. Fine. Then later we started with the RAM memory. Okay, fine. And in that RAM we discuss about the SRAM. Even we discuss about the DRAM. Fine. Okay. Then later we started with the hybrid memory. So in this hybrid memory, I'm categorized like here double EPROM. I'm putting under the hybrid memory. Then you can see your flash memories. Whatever is the NAND memory, NAND flash, and whatever is the NOR flash, it is a part of what? Your hybrid memory. Clear now? Okay. So still if anything is not clear, go through the recorded session. Friday session is not uploaded yet. Fine. I will inform to upload. Somebody else is uploading. I will inform the respective person. Fine. It will be done soon. Okay. Fine, so this is about the embedded system memories. Okay, now let me go to the next component, guys. We are still in the second component. Okay, next component of embedded system, if you ask me, you can consider that as a sensor. Okay, so what will be the next important component? You consider as an sensor. So if see here, but people, if I talk about the sensor, what will be the output of the sensor? Don't you think it's going to be analog, right? It will be analog. So is microcontroller working on the analog signal? Is our microcontrollers working on the analog signal? No, it need a digital signals, right? It works on ones and zero digital signal, and output of sensor is going to be analog. So what you need in between, you need a ADC to convert this analog signal to the digital signal. Understood? And then people, based on whatever input given by the sensor, if you want to take the action, then here comes the need of the actuator. Then again, actuator works on the analog signal. So in between the microcontroller and actuator, you need a DAC. Okay, digital to analog converter. Let's say, for example, let's say sensor is sensing the temperature. Let's say temperature range is above the threshold temperature value, then it will inform to the microcontroller. Microcontroller will see that temperature. So obviously, if it is more than threshold temperature, what microcontroller has to do? This fellow has to turn on the fan. So it will inform that to the actuator, and for the cooling purpose, actuator will turn on the fan. So this will be the actual feedback system, closed loop system. Okay, then later you might be having another important component in your embedded system is might be human interfaces. Okay, what it will be? Human interface. So human interfaces, lot of are there. You can see the LEDs, like LEDs are mentioned in case of, let's say in your laptop, are you able to see the LED, right? So when it is charging is going on, LED is blinking, or even in the mobile phone also. So what it is? Human interface. So you can have a human interface as small as LED, or it will be as big as the LCD also. Fine, or SSDs also you can use. Fine. Anything, I'm just taking an example of the scenario to explain it. Okay. Then again, next component might be diagnostic port. So guys, nowadays if you see, lot of components, lot of embedded systems are coming with the diagnostic port. So what is this diagnostic port will do? So this diagnostic port, it will check everything is working fine or not, kind of diagnosis it will do. So if is there any issue, it will try to, or it will try to inform, or it will try to it will in simple term try to do diagnosis of that issue under this diagnostic port itself. Fine. So in few system it might be there, or in future for all the system you are able to see this. Okay, then next important component you might be having FPGA or ASIC. Any idea, people? FPGA stands for what? Guys, do you have any idea FPGA is what? FPGA is nothing but the field programmable gate array. And what is the ASIC? ASIC stands for what? Application specific integrated circuit is nothing but ASIC. What is FPGA? FPGA is nothing but field programmable gate array. ASIC is nothing but what? Application specific integrated circuit. Okay. Now see here. So okay, so either you will be having FPGA or you will be having the ASIC. So when to use the FPGA, when to use the ASIC in the embedded system? So guys, if you are designing the embedded system and which will be in the less quantity, then better to go with the FPGA instead of ASIC. So if you are designing the product which is in the less quantity, then go with the FPGA. And otherwise, if you are designing the product, it's lakhs of products you are designing, and then it's better to create. Yes, correct, Akshay. It's better to go with the ASIC. So what you can do? You can create a IC for the specific application, okay? And then later from that ASIC, you can start creating the IC if you have multiple products. If it is multiple production, then using a ASIC is cost effective. Otherwise, it will be very costly for the smaller amount of production. Okay, that time you go with the FPGA. Fine. Okay, so these are the few important components of the embedded system. Okay, then another most important component of the embedded system, usually we ignore that, which is nothing but the power auxiliary system. In that, it's a power. So people, you see the different components in the embedded system. All the components are working on the same power supply. No, they are having different. If you are working on 10 volts, 5 volts, 2 volts, right? So guys, you have to design a power supply such a way that all the systems are working fine without any issue. Understood? So you have to do the design. People ignore that, but let's say your designing of embedded system is very good, no issues. But what happened? What happened? Your power supply is not good. Is there any use of anything? Do you understand importance of the this one power supply? So you have to design this such a way that everything will work finely. Understood? See, human interface means, okay, or let me complete the last component. And then software is, don't forget, software is also component of your embedded system. How you are going to program this microcontroller? By using the software. Understanding? So these are the few important components of the embedded system. So you might be including the other components. So based on application to application, components will change. Understanding? So these are the, at least these components you will see in your embedded system. If anybody asks you to mention the different components of embedded system, at least this you can include. Or if somebody is asking to draw a block diagram of embedded system, you can draw this. Okay, and you depend that vary anything based on the application. In general, I'm talking here. Fine. Now, guys, if you didn't understood anything, Hearth Solanki, just give me some time to complete my topic and come to your doubt. If impatient, if you keep posting, didn't understood, how I will be able to explain that in between the topic. You understand? Human interfaces means the things which are used to interact with the machines by humans, or in simple term, let's say in your laptop, how do you know charging is going on or not? Let's say you have a laptop, how do you know whether it is getting charged or not? May I know? Okay, first is screen. Okay, let's say you close the lid of your laptop. Okay, and then how? Let's say screen is not on right now, but your charger is connected. So how do you know? There is a LED, right? What is this LED? It's human interface. It is for us, for the human purpose. Otherwise, let's say if that LED is not working, let's say if something is goes wrong, then don't you think if LED is not on, you will be understanding, oh, charge is not going on. Understood? Yes, you can say that keyboard is human interface. You can say that. So, like that way, I'm saying that in your embedded system, you're having the human interfaces like from LED, like SLD, or big screens of like LCD also. You will be see in your embedded system. That's what my concern. Understood? And regarding FPGA and ASIC, see people, it is just an introduction. Okay, I don't want to go in detail. We have to complete the syllabus or project on time, main things. So here, if you invest too much time, we will be getting lesser time to work on the project. Try to understand. Diagnostic port means what? Port which is might be doing the diagnosis of the system itself. If is there any issue, at there itself this port trying to resolve that issue, or at least if you are referring the embedded system to the diagnosis, what goes wrong, that information might be you are able to see in this diagnostic port. Understanding? And FPGA and ASIC means what? As I said earlier, let's say you are planning to include, okay, FPGA, either to include the FPGA or to include the ASIC, it is depending upon the production. How much quantity you are doing the production. Okay. So let's say you are doing the designing in the lesser amount, or you're doing the production of embedded system in the lesser amount. Okay. Then in that case, it's cost effective if you go with the FPGA. Understood? But if you are designing the production, if your production in terms of lakhs, okay, then in that case it's better to create one IC, application specific IC, and then based on that IC you can create, based on the ASIC you keep creating the IC, then in that case it will be cost effective. Otherwise, just for the 5 to 10 quantities, if you are designing the ASIC, then it is going to be very costly. Fine. So this is about the different components of the embedded system. Understanding at least basic things. Are you able to follow me, people? Yes? No? Fine. So a lot of other things might be there. Not possible to see these things later as we proceed further, as we start using it. We are going to see in detail. Understanding? Fine. Okay. So let me go to the next slide. That the next slide is talking about the requirement of the embedded system. So what will be the requirements of the embedded system? So few requirements are mentioned here. So first requirement is nothing but the reliability. So people, if you are designing the embedded system, make sure it is reliable. So reliable, if you ask me from the common people point of view, it's something like a warranty guarantee. So if your product is not reliable, then what happened? What happened? At the end, your market value will goes down. So now, for example, let's say I'm designing the, let's say you are designing the embedded system. You told me, okay, so your embedded system, whatever product you design, it will, you are giving me the 1 year of warranty on that product. So but that product is costly, little costly, but since you're saying that you're giving me the 1 year, or let's say you're giving me the 2 years of warranty, so I believed in you, I purchased your embedded system, then later it's not working at all. So don't you think it's not reliable? Whatever you said, it's not working accordingly. So guys, if it is not reliable, then am I going to refer your product to my friends, to my family members, your embedded system? Answer is no. So what happened? The market value will goes down. Understood? So make sure whatever product you design, it is reliable. The next is cost effectiveness. So make sure your embedded system is cost effective. People will able to afford this, then only they are going to purchase. If it's very costly, so very few people will purchase it, your business is not going to run. So your business is not going to work that well. So you have to design the cost effective product. Fine. And then make sure there is a lesser consumption of the power. Okay. By the way, if you are using this point, covering this, automatically you will consume the less power. So what it is saying, that it is saying that efficient usage of the processing power. So basically I'm so sorry, basically whatever processor is there, use it efficiently. Whenever it is required, then only make it run, then only make it use the power. When it is not needed, unnecessarily don't make your processor run. That time save the power. If you are making the processor use the power efficiently, then obviously you're going to consume the low power. And same way, use the available memory efficiently. Microcontroller is having the built-in memory. So whatever code you will be writing, you need to make sure that written code will fit into the available memory. Or even later, if user is going to come with the second or third requirement, you should be able to update the code, and that code must fit into the available memory. When this will happen? If you use the memory efficiently. So this is about the few requirements of the embedded system. Understood? Break you want in between? Oh, others? Just 1 hour we completed, right? Focus, focus. At least focus for next half hour. Everybody? Okay, see ya. Next is about the few challenges we may face while designing embedded system. So people, what are the challenges we may face? Actually, getting the efficiency might be the challenging in case of embedded system. I mean, for the given input, getting the correct output is nothing but the challenging. For the given input, getting the correct output is challenging sometime in case of embedded system. Means, for example, let's see this diagram. Okay, pay attention. I'm drawing here itself. Let's say this is your microcontroller. Fine. Now let's assume to this microcontroller I'm connecting a switch, something like this. Okay. Now see, usually this tactile switch is represented by this symbol. You see, this is how it is represented. Like this means switch is open. If you press the switch, what happen? Switch will make the contact with these two terminals, and like this way it will be closed. Fine. Okay, now see the scenario. See this embedded system connection. So now if you observe here, let's say I'm pressing the switch. Okay. So as soon as switch is pressed, it will make the contact and connection is completed towards the ground. So this end is, let's say, ground. One end of the switch is connected to the microcontroller pin, other end is grounded. So as soon as I press the switch, what happened? Connection is towards the ground. So what will be the signal at this microcontroller pin? What will be the signal at this microcontroller pin? Now, one more thing. in embedded system here onwards, always if I'm saying 5 volt, okay, or VCC, VDD, whatever it is, if I'm saying it in digital word, it is nothing but the 1. Okay, and if I'm saying that, remember 0 volt or ground signal in digital word, it is nothing but the 0. So please talk in terms of zeros and 1. Okay, so I'm getting the mixed answers. Okay, at least, may I know where this pin is getting connected on switch press? Don't you think it is connected towards the ground? Don't you think it is connected towards the ground, right? So here you will be getting the signal 0. Fine, when switch is pressed. But what about switch open? If I open the switch, then what will be the signal at this pin? If I open the switch, what will be the signal at the same pin? Don't 5 volt, you are saying literally 5 volt, but guys, in the previous case you said 0 because connection was towards the ground. But here, are you able to see this pin? It is connected anywhere? No. Don't you see this line is floating? Nowhere it is connected when switch is open. Agree? Come on. Answer literally what you see. When you press the switch, what happened? Connection will be completed like this towards the ground. That's why you said 0. When switch is open, this line is floating, nowhere it is connected. So in that case, what happened? Noise signal may affect this line, and without giving any input, you may get the signal here 1 or 0. This might be challenging. This is what for the given input, getting correct output is challenging due to the your hardware. So what is the issue here? So it's a simple circuit. Pull up is missing. If you are adding the pull up like this, then no issues. Fine. So here, this is the first challenge. What for the given input, getting the correct output. So getting 100% correct hardware is also another challenge in case of embedded system. Fine. Okay. Then next challenge is nothing but the embedding and operating system. So now guys, if you decide or if you're working on very complex embedded system, if you're doing very complex application, then might be possibility that you need a operating system. You have to include the OS in your embedded system. But guys, embedding an OS is that easy? No. For that purpose, you need detailed knowledge about the OS, about the operating system, what it is. Then you are going to decide all the algorithms, means whatever subsystem operating system is having, all the subsystems are you going to include in your embedded system. Then what scheduling algorithm you will be using. So if you ask me, this is very in detail. So you need a detailed knowledge about the operating system first. So that's why this kept it under the challenge sheet. Understood? The next challenge might be code optimization. So first of all, what do you mean by code optimization? What is optimized code? May I know, people? Line reducing the line, that doesn't mean optimize code. So see here, optimization we are talking in terms of space, in terms of memory and the time. So can I say people, optimize code means best piece of code which further we can't optimize in terms of space and in terms of time also. That is nothing but the code optimization. So now, why this code optimization under the challenge sheet? Because see, to do the code optimization, you need a experience. As you are getting the experience, you will be able to do the code optimization. So right now, if you ask me, in front of you, first, what is the challenge right now? You want to complete your engineering. That is the first challenge. And once you complete your engineering, what is the thing? You have to get the job. And then again to do the code optimization, you need a correct experience. Then only you can do the optimization. That's why it is kept under the challenge. Understanding? Then another challenge could be testing and debugging. So a lot of companies, a lot of big companies also facing this as a challenging. So doing a testing, getting the 100% thing tested is a bit challenging, and even doing the debugging for a few errors is challenging in case of embedded system. Understood? These few challenges which you may face in designing the embedded system. Getting it, people? Nathan, that is covered in the next point. Whatever we are discussing here, it is making sense to everybody? Okay. Then next sheet is about the trends in the development. So first of all, what do you mean by trend? Trend is nothing but the fashion, kind of fashion. Okay, fine. Take a break. I will continue at 8:15. Take a 3-minute break since many of you are requesting. I will continue at 3:15. Fine. Yeah, I can understand too much theory is there, but we have to cover it before we starting the implementation. Yeah, have a water, relax, and we will continue around to 8:15. Fine. Yes, Nitin. I was the one who gone through the installation session. What happened? Prakul, in next 15 days we will complete that. Fine. Regarding your assignments, okay, fine. So regarding your assignments, so whatever you done regarding the C, that's fine. So now totally focus on this project. What we are going through here in embedded system, please focus here. Fine. So anyways, if you didn't submitted any assignment, that's fine for now. Okay. You can say Mohan in one way we can say that. Marks here on the same test. Those are okay. Let me check, Naren Kumar. Grades are all open or not? Might be grades are kept closed till the everybody wrote the exam. So I will check with the same mentor and update you regarding the grades. Fine. Sandeep, we are going to see the difference between microcontroller and processor. Fine. I don't know, Prakul, what is the assignment and these things regarding the previous C. We will see in case of my model, means this embedded programming. Fine. So if you have any query, guys, related to the C, you can check with the Anusha ma'am in the discussion forum. Fine. Okay, even for the weekly test one, if you have any issues or if you have any query, you check it. Okay, chalo, now 2015, 8:15 already done. So can we focus here? Yes, all tests are considered for the certification. Don't miss the test, and no test will be reopened. Make sure. Okay. Agenda for the next week, Kedar, have you attended the last class? So as per the last class, what is our agenda? We got the detailed explanation about the project. So first we will be going through the introduction to the embedded system, even microcontroller introduction. Then later we will see the peripherals, how to work on that. And in the last week, we will integrate all those prepared peripherals together and complete our project. Fine. Okay, Vidya, if you didn't attend the test, please do attend the next test without fail. Okay, fine. So everybody now focus here, focus on the important thing. Now next is nothing but the trends in the development. So what do you mean by trend? Trend means kind of fashion, right? Now let's see guys, even if we are going into the market to purchase a jeans, lot of trends are there, lot of choices are there. Am I right? So here also, in case of embedded system, in the development also we are having lot of trends. We are having lot of choices. The first choice itself is your processor. N number of processors, microprocessor, microcontrollers are there in the market. So which one you want, you decide based on your application. So for example, let's say your embedded system, you want to need a adc in your embedded system, your application need adc, then there are few processor which having the built-in adc, you pick that one as per your need. And memories, if you talk about the memories, don't you think people, lot of choices again are there in the memory, right? We discussed a lot of memories just now in today's session, correct? So or depending on your requirement, you pick the memory. Now let's say people, I want to store, okay, my data is going to be consistent and just a few bytes of data I want to keep rewriting. Then which memory is the best suitable for me? Don't you think in this case my choice will be the double EEPROM? Few bytes, small amount of data. If you keep rewriting it, then best solution will be the double EEPROM. Understanding? And if you want to store the code, then which memory you will prefer? NOR flash, right? And if you have more amount of data, better to go with the flash memory. Understanding? So what is my point? There are a lot of choices in the memory. Based on your need, you're going to pick the suitable one. Then operating systems, again, if you're planning to embed an OS in your application, then again in that also we are having the choices. If you are the open source or if you are the paid OSs, means if you talk about the open source, you can see the Linux OS, it is open source, that is free, correct? And if you are the paid operating systems like Windows, so based on your budget, based on application, you have to pick the OS, okay? Then again, many programming languages are there, right? So you can see there is a C, C++, Java, Python, and number of languages are there. So based on your application, in which you want to try, which you want to implement, or which language you know at the end, you as a developer, which language you know, you're going to pick that one, fine? And then development tools. A lot of development tools are there. So Based, a few of them are again paid, few of them are the free versions. So whichever you want, what is your budget, you pick the suitable one. So this is about the different trends in the development. So at the end, we guys don't forget about the cost effectiveness. Make sure your final product is cost effective. Fine. The next point is about the next slide is about the common design matrices. What are the different common design matrices? If you see, first is nothing but time to prototype. So, first of all, may I know what is prototype, guys? What do you mean by prototype itself? People, do you know what is a prototype? Make sure I'm not talking about the protocol, I'm talking about the prototype. Prototype is nothing but yes, model, demo of output, test model, sample output, not a protocol, Baba. That's why I said I'm not talking about the protocol. I'm asking prototype. So prototype in simple term, if I collect everybody's answer together, I will say prototype is nothing but base working model, right? Whatever basic, whatever sample working model is nothing but the prototype. Now, what is this slide is saying that time to prototype is, I'm sorry, time to prototype is very important. Don't invest much time in just designing the basic working model, basic prototype. If you are investing the much time in prototype instead of creating that product, or then what happen? If you're investing much time in the prototype itself, then the time to market will affect. So obviously, if you invested much time in the prototype, you will be coming, you are releasing your product late in the market. Time to market will affect. So don't forget, you are not alone in the market. Other competitor are there. So if you are coming late in the market, somebody else already launched the similar product, then first amount of that product you will not be getting. So obviously your business will not run as expected. So make sure you are designing the prototype on time and you are coming to the market on time, whichever that you mentioned. Okay. And then power is also very important. So design the power supply such a way that it will not affect the working of component. Every should work perfectly fine. The next point is about the performance and correctness. So make sure whatever performance you want for your embedded system, either speed or time, it is as per that, and even it is performing correctly. Then size of your embedded system. So guys, whatever embedded system you design, if it is going to be handy, then try to keep the size as small as possible. Otherwise, size doesn't matter much. Make sure if it is that product is going to be handy, keep the size as small as possible. Okay. The next is nothing but NRE, non-recurring engineering cost. What do you mean by NRE? Sometimes people, even if you did the, even if your product is successful, then if that time you will not get your 100% investment right back. That is nothing but the NRE, non-recurring investment cost. So though your product is 100% succeeded, you will be having some losses. Whatever 100% investment you are not getting back, that is nothing but NRE cost. Okay. The next point is about maintainability and the flexibility. So make sure your NRE, non-recurring engineering cost, NRE. Maintainability. Next point is maintainability and flexibility. So make sure people your product is easy to maintain. Don't design too much complex, okay, so that the people who are working on it not able to maintain it. And make sure it's flexible. So now let's say I'm installing your embedded system in my company, and since due to some reason I removed that product, my entire company, lot of machines are not working. It should not happen. Things will work flexibly even without that also fine. Then safety. If your embedded system is going to deploy where humans are there, then very first thing you have to take care is about the safety. Safety comes first. Okay. The unit cost, make sure your product is having a unit cost, people are able to afford it, then only your business will run. And already we discussed the time to market. So these are few things we need to keep in mind while designing the embedded system. Understood, everybody? Okay, see, repeat the NRE. So what NRE? NRE is nothing but the non-recurring engineering cost. See, what do you mean by NRE? It is nothing but non-recurring engineering cost. So what happened, people? Let's say you are developing some product, you are doing some design, and that production, that design is what? Successful. It is succeeded. The product is successfully, you got the success in your product. There is no problem. But whatever 100% investment you did now, you will not get that back. There will be some loss. Okay, that is nothing but the non-recurring engineering cost. Let me take one example. Let's say uh, I have one client, and that client is asking me to give me the design of the embedded system ABC. So you want the embedded system design ABC, okay? Now, what I did, in my firm, I hired three engineers. Okay, one engineer is working on the part A, another engineer is working on the part C, or part B, and one more engineer is working on the part C. Okay, so at the end, my three engineers completed this part. So I just combined those that together, and I completed the design of this EBC system. Okay, so once designing is completed, product is completely ready. Yeah? So what I did, I called my client. So client came. Client is happy. He said, yes, exactly. This is what the product I want, EBC. But now client is saying, the C part doesn't look good in this embedded system. Just give me the part A and B. Just client want embedded system with the part A and B. Client doesn't want the C part. So guys, I hired one engineer. That engineer is working on the parts C from the past few months. Now suddenly client is coming and saying, I don't want the part C. Then who is going to pay the salary of that fellow which is working from the starting on that part? Now suddenly you're saying you don't want it. So don't you think I have to bear that loss even though ABC product is successful? Understanding. So this is nothing but NRE cost, non-recurring engineering cost. Understood? Okay, fine. So next is about the difference between the GPA and embedded system. Okay, fine. So let's stop here, people. So I can say that too much theory. So tomorrow, very few things are pending. So we will complete that tomorrow, and mostly we will go ahead with the peripheral programming from tomorrow session onwards. Fine. Okay, so don't miss that session. Okay. We cannot compensate. That's why it is NRE, non-recurring engineering cost. We have that. We have to bear that loss sometime, even if product is successful. Understanding more. Fine. So that's it for today, people. Thank you. If you don't have any doubt, you can leave the session. Others, if you have any queries, let me know. So I will answer your queries. So first of all, regarding the test, if you are talking about the test, I will inform to release your score. So you check the score in the LMS itself. Okay. So might be scores are not yet released because few people we are still working on the test. Fine. So that will be released soon. I will inform. Anything else? And installation. I hope everybody completed the installation. I hope so. Officially, we are using the discussion forum, Nitin. Officially, there is no WhatsApp group. Yes, it is important to attend the test. You have to attend it. So don't miss the test. Those will not be reopened again. In the next 15 days, we will end the internship, Kedar. Mostly in this month, we will try to end it. In next 15 days, I will complete the things from my side. I hope you all are enrolled for in the LMS. I hope so. We have online simulator, Ravi. As we start using it, we will see that. Bhargya, from tomorrow onwards, we will be starting the microcontroller programming. What project do you have, Aditya? I hope you attended the last class. Go through the last class recorded session. Fine. Of passing marks, you please check by putting the query in the discussion forum. Use the website, Chetan. I don't think so there is a suitable app. Use the website. Web only better. Installation session already, Prithvi, we covered it. Either go through the recorded session or the documents uploaded in the LMS. You please download that and follow that document for the installation. Tech basic, Ramya, even we are talking about the basic. So, but whatever basic you are expecting from tomorrow onwards, I will be starting. Priyanka, around 12 more classes I need to complete this. See, even if you are scoring less now in the starting test, that's fine. Do good in the next test, fine. Submission, Keda, let me first complete the project itself, then we will talk about the submission, fine. Yes, it is very important to attend the test. Don't miss the exams. I will guide you to the project together, Bhumika. It will be code along session. We will be doing it together. NVRAM, I didn't covered it because NVRAM is extended version of the SRAM. Okay, so if you know about it more, that's good, fine, no problem. So Kedar Patil, we will talk about the submission later. Let me at least start with the project implementation, fine. Okay, so the project, which project we discussed, we are working on that with the Shri. I hope you attended the last class. Bhupinder Singh, actually no, you will not get it as a PDF. I'm so sorry. Okay, Shartak, that's fine if you are missing the session due to the exam, that's okay. But later go through the recorded videos, otherwise you will not be able to understand it, fine? Okay, Vivek, then in that case, you please use the online simulator. How to use it, I will guide you, don't worry, fine? Assignment, you please, I don't know the regarding the assignments of the previous C model which was covered. So you please put that query in the discussion forum. Vivek, I'm saying that let's use the online simulator in that case. Yes, yes, one project for everybody. We will be working in the group and you are submitting it, fine? No, you can work in groups. What will be the group size and all, I will let you know. Maximum, I guess, 3 people we are allowing in one group. Yeah. Fine then, people. So let's stop here. So if you have any queries, you please post it in the discussion forum. I will answer there. Okay. Certificate, once your evaluation is done, you will get the certificate. Fine. Okay. Thank you, everybody. So let's stop here. So you please post your queries. If I have missed by mistake, a lot of queries I'm getting on the screen. If I missed anybody's query, we will see that. Fine. Yes, people, if you don't have any doubt, you can exit the class. No problem. Yeah. Thank you, everybody.